After molten metal is poured into a mold, a series of events takes place during the solidification of the metals and is cooling to ambient temperature. These events greatly influence the size, the shape, uniformity, and the chemical composition of the grains formed during the casting, which in turn influence the overall properties of the metal. Significant factors affecting these events are the type of the metal, the thermal properties of both the metal and the mold, and the geometric relationship between the volume and the surfaces area of the casting, and of course, the shape of the mold. It's required to heat the metal to a molten temperature sufficient for the casting. The heat required is the sum of the heat to raise the temperature to the melting point, and the heat of fusion to convert from solid to liquid, and finally the heat to raise the molten metal to a desired temperature for the pouring. For a successful pouring of the molten metal, the metal must flow into all the regions of the mold, most importantly the main cavity, before solidifying. The factors that determine the success are the pouring temperature, the pouring rate, and the turbulence. Transformation of the molten metal back into a solid state is known as the solidification of the metals. Solidification differs depending on whether the metal is a pure element or an alloy. A pure metal solidifies at a constant temperature equal to its freezing point, same as the melting point. Due to the chilling action of the mold wall, a thin skin of solid metal is formed at the interface immediately after the pouring. The skin thickness increases to form a shell around the molten metal as solidification progresses. The rate of the freezing depends on the heat transfer out of the mold, as well as the thermal properties of the metal. As most alloys are a mixture of two or more metals, the most of the alloys solidify over a temperature range. Accordingly, the characteristic grain structure in the alloy casting showing segregations of the alloying components in the center of the casting. Total solidification time is the time required for the casting to solidify after the pouring. The total solidification time depends on the size and the shape of the casting by a relationship known as the Cherepanov rule. The mold constant Cm depends on first, the mold material, second, the thermal properties of the casting metal, and finally, the pouring temperature relative to the melting point. The value of the Cm is given casting operations can be based on an experimental data.